Hi everyone, in this lecture we will discuss how you can use the inbuilt function provided by C++ algorithm header file to make your work easy while doing questions online. Okay, so it's not required that every time you want to solve a sorting problem you have to write your own sorting function. What you can do, you can take help from a sort function that is already available with the C++ standard template library. Okay, so the first thing that you need to do is you need to include this header file called hash include algorithm, and this contains a sort function. Okay, so what we are going to do, we are going to take input a array and then we are going to sort it using the sort function. So the sort function accepts multiple parameters. Okay, so let's talk about the first parameter is the starting point of the container. Okay, so we will not call this as the starting point of the array, but it can be a container. Okay, so when you work with the standard template library, a container can be anything. Okay, it can be a array, it can be some other data structure like vector or anything. Okay, so what we will do, we will say we are going to sort an array in the beginning. So the starting point of the array will be the starting address of the array. Okay, so this starting address of the array is a, and another parameter that you should give is from what position to what position you need to sort. Okay, you need to give start and end, and remember when you call this sort function, the starting point is included and the ending point is excluded, which means if you want to sort this complete array, the last index although is array plus n minus 1, but you actually have to give this particular index. Okay, because this index is not included. So if you want to sort an array from this point to this point, you have to give the start as a and you have to give the ending point as a plus n. And let's try to sort this array using this sort function. Okay, so let me say the starting point is a and the ending point is a plus n, and this will actually sort the entire array. So we have not defined this sort function. This sort function is already defined in this header file called algorithm, and it's much more efficient than the basic sorting algorithms like bubble sort, selection sort, insertion sort that we have done till now. And maybe in some time later we will also talk about other sorting algorithms like merge sort, quick sort. So this sorting algorithm is quite efficient in terms of time complexity, so you should prefer to use this sorting algorithm instead of writing your basic sorting algorithm such as bubble sort. Okay, so let's try to run this, and let me just call this as inbuilt sort, and let's say we have 6 elements and the elements are 6 5 4, let's say 1 2 3. So you can see we are getting the correct output, and it's not like that we can sort elements always in the increasing order. We can also sort these elements in a decreasing order. So for that we need to do one thing, we need to define a comparator function. Okay, so we have to define a comparator function here. Okay, so what we will do, we will have a function bool compare that actually compares two integers. Okay, so it will tell the sorting algorithm how do you compare two integers. So what this compare function will do, I will tell you. Let us first pass this compare function. Okay, so here we are not calling the compare function, here we are uh, sending a function as a parameter to another function. Okay, so this is something different that you have not seen till now in the course. So sort function is accepting another function that basically compares two numbers. Okay, so I will explain you what this thing is going to do, and let me just first run this code, and let me see, there are 5 elements 1 2 5 4 3, and you can see we are getting these elements in the sorted order. But suppose if I reverse this comparison, I say okay, return true when a is greater than b. Okay, so let me say 5 elements 1 5 4 3 2, and this time you can see the order in which elements are appearing has changed completely. So instead of doing an increasing order, we are now able to sort the elements in a decreasing order. So we actually have to understand how these comparators work. So let me go to example of bubble sort where we have done something like this. Okay, Okay, now suppose this is bubble sort, and this is the logic of the sorting algorithm. So what we can do in this logic, we had written if condition. We had written if aj is uh, aj is greater than aj plus 1, then we will do the swapping. Okay, so such a condition will be always there in any sorting algorithm. For example, if 4 is there and 5 is there, and if you want to bring this 5 here, you will say, okay, if 4 is less than 5, then swap it, or if 5 is greater than 4, then swap it. Okay, so something like this you will have in every sorting algorithm. So what you can do, instead of fixing this comparison logic at this point, what you can do, you can just make another function called bool compare, and the goal of this function will be to accept two numbers, a and b, and it will just compare uh, when to return to. Okay, so you will say, okay, if a is greater than b, in that case you return true, or if b is greater than a, in that case you return true. So if you just change this execution of this particular if statement, you can actually change the order in which the elements are getting swapped. All right, so what we are trying to say, the sort function is something very similar to, let's say, bubble sort, and inside it has a if condition, and instead of directly writing a comparison at this condition, you can just say if compare aj and aj plus 1, you will do the swapping. Okay, you will do swapping if this compare function returns true. So what we are trying to do in our case is, we are fixing this logic outside the sort function, and that sort function is internally calling this compare method to compare two elements. Okay, two elements of the array. So if you want to actually see this function is getting called multiple times, you can put a cout statement here, and you can say comparing a and b. Okay, so let me run this code now, and although we have not called compare function anywhere till now, we have just passed this function as a parameter. Okay, so this is uh, we are passing the function name as a parameter to the sort function. Okay, so this is what we are doing, and this function is called internally. So internally in this sort function, you will have something like this: if compare a comma b, or ai comma ai plus 1, then do the swapping. Okay, so this is going to be called internally. So let me show you, and if it is called internally, then you will see this cout statement multiple times. The number of times this compare function is called internally by the sort function. So let us try to run the code, and let me say the elements are 5 4 3, and you can see the comparisons are happening. Okay, so these comparisons are done internally, and what we did is, we just modified the order in which the sorting function is going to produce an output by sending it one more function, that is the compare function. Okay, so I hope you got a little bit idea how to use comparators, and this is very useful when you want to compare strings, when you want to compare different type of objects. Maybe you want to compare numbers based upon number of digits a number has. Okay, for example, if you have a number, let's say 1199, and you have a number called 199, you want to say, okay, this number has 4 digits, I want to put those numbers in the beginning that have more number of digits. Okay, then you can write your own comparator function that makes the comparison based upon number of digits in a number. Okay, and we will see more examples in coming videos. So I hope you got a brief idea of how does a comparator function works.